Hey everyone, welcome back to Cam Room 5. So in today's video, we're going to be talking about a new kind of electrolysis, that is the active electrode electrolysis. If you remember, we have been talking about inert electrodes for a while, but this time we're talking about active electrode electrolysis and their applications. So what is an active electrode? The word active means it is actively participating in something. So what is it participating in? It participates in the electrochemical redox reactions. So active electrode participates in the redox reactions going on during the electrolysis. For example, the anode itself is oxidized and the cathode is itself reduced. So the anode itself will oxidize itself, it will lose its own electrons, and it will start dissolving. So you can see that the anode's mass by the end of electrolysis will decrease. The cathode itself will reduce. So the ions will go to the cathode and they will be the same ions on the cathode. So they're going to reduce themselves and the mass will increase. Imagine you have two copper electrodes. That's why I drew them with a pink color. There's an anode and a cathode. The plus one is the anode and the minus one is the cathode, and both are made up of pure copper. Imagine, like hypothetically, they are 100% pure copper. So we have a copper cathode and we have a copper anode. The solution needs to have the same ion as in the electrode. So copper electrodes will have the electrolyte of copper sulfate. It can be copper nitrate or copper chloride as well. I'm concerned with just copper ions. So what happens is, on the cathode, you will see reduction and anode is oxidation. So let me write, copper will oxidize itself, losing 2 electrons and become copper ions. And you will see the electrons will move to the wire because after the oxidation, the electrons are released. They're going to go through the wire towards the cathode. Whereas the copper ions, after the oxidation of the anode, will be released in the solution. So the copper anode will oxidize itself and release copper ions in the solution. These same copper ions will go to the cathode where they will reduce themselves. So the electrons are coming from the wire and the copper ions are in the solution, and they're going to go to the cathode where they will reduce themselves by gaining 2 electrons. So gradually you will notice that the anode is oxidized, it dissolves, and the cathode is reduced. So there will be a change in the mass as well. You will gradually notice that the mass of the anode changes and as well as the cathode, whereas there will be no change in solution because the concentration of the copper ions in the solution remains the same. They are released from the anode after oxidation, but they are reduced on the cathode. So they are not staying in the solution. The amount of copper ions will remain the same, so the color will also remain the same. Similarly, let's talk about the applications of how this active electrode electrolysis works. We're going to talk about 2 things. One is going to be electroplating and the another is purification of extracted metals. First is electroplating and the second is going to be purification of metals. If you have talked about the extraction of aluminium or copper or iron, we purify them by the process of electrolysis. So let's see how electroplating works. Obviously, electroplating means you're going to cover a rather ordinary metal or rather cheaper metal with a layer of more expensive, more noble metal. So it's coating an expensive or more noble metal on an ordinary, rather cheaper metal. A metal with not a very good luster, a metal with not very good properties. So imagine you have a beaker and you have an iron spoon and you want to coat the iron spoon with a layer of copper. So the iron spoon, let me write. The iron spoon is your object that is rather a cheaper product and you want to coat it with a layer of pure copper. So you need a piece of pure copper as well. You need a source of copper, right? And that source of copper is going to be a copper electrode. You connect the spoon or the material to be plated on the cathode and the source of expensive metal, which is the electrode on the anode. So the copper as a source of copper layer will be our anode, and the iron spoon, which has to be coated with a layer of copper, will be used as cathode. You need to make sure that they are connected to the correct terminals of the battery, obviously. The solution needs to have copper ions. Let's recall that the more expensive, the more noble metal is going to be the anode. The material which is cheaper and has to be plated is going to be the cathode. The solution needs the same ions as there are in the anode, the metal which you need to create a layer of. For example, in this case copper, so you need copper chloride, copper sulfate, copper nitrate, whatever, but you need copper ions in the solution. So all these salts are soluble and they are a good source of copper ions. And that is why the solution is blue, by the way. So what happens is that as soon as the current is applied, the anode will start to oxidize itself, copper ions will be released, and these copper ions will start going towards the cathode. On the anode, the copper will oxidize itself, so copper metal atoms will become copper ions and they will lose 2 electrons. These same copper ions will go towards the cathode while the electron will be released in the wire. However, on the cathode, copper ions will gain electrons and they will start becoming pure copper atoms. So you will see a layer of copper depositing on the spoon. You can see the spoon is gradually becoming pinker and the anode is reduced in size. Let's talk about purification of metal, which uses a similar kind of electrochemical redox reactions. Now you have 2 pieces of copper. You are connecting them with a piece of your voltage supply, a battery or a cell. Now you need to know that you have a piece of pure metal which is going to be the cathode, and a very bigger piece of impure metal is going to be the anode. A very small thin piece of pure metal is used as an investment to be supplied as the cathode, while a bigger piece of impure metal, the one which has to be purified, is used on the anode, is connected with the positive terminal. Just recalling that you're getting this impure metal from the metal extraction, like iron extraction, like copper extraction, aluminium extraction, whatever. The solution is again the electrolyte which contains the same ions. In this case, it needs to have copper ions, but if you were purifying iron, you would need a solution containing iron ions. If you were purifying a piece of nickel, the solution would need nickel ions. So since we are talking about copper, our solution is likely to have copper ions, like again copper sulfate or copper nitrate, etc. And copper ions are blue in color, so you need to have a blue solution. Pure copper is on the cathode, impure copper is on the anode. The solution contains copper ions, again in any form, any salt of copper. I've already given you multiple examples. You can't use copper oxide, you should know this, because copper oxide is insoluble. You need an aqueous solution. You can't use any other copper compound like copper carbonate, which is also insoluble. So it has to be soluble. Similar process will occur that on the anode you will see oxidation. So the anode copper atoms will start oxidizing themselves and they will release copper ions. These same copper ions will go to the cathode where they will reduce themselves. So on the anode you can see that copper atoms which have no charge on them, they lose their electrons and they become 2+ ions. So this is oxidation happening on the anode. This is common, like this is usually happening because anode is always oxidation, and on cathode the copper ions will reduce themselves to make pure copper. This is reduction. The size of anode will decrease and you will start seeing the cathode size increasing. So by the end, the anode will reduce in size and the cathode will increase in size. There may be impurities in the impure anode, so you can see anode sludge, a substance called anode sludge, as impurities settling at the bottom of the anode. This can have unreactive metals like silver or gold. So anode sludge has impure substances which settles at the bottom. I hope this idea is clear to us, And the coming video, we're talking about some new topics. Stay tuned, guys. Thanks.